Hello everyone, morning to all. Myself Sivalingam Sengottaiyan, Professor, Department of Mechanical Engineering, Coimbatore Institute of Technology, Coimbatore. Today we are going to discuss about basic concepts of engineering, thermodynamics. Now, what is thermodynamics? Thermodynamics is nothing but science of energy. It deals with the most basic process occurring in nature. The term thermodynamics stems from two Greek words. Thermo means heat, dynamics means power. Let's begin with law of nature, that is conversion of energy principle. It simply states that during an interaction, energy can change from one form to another form, but the total amount of energy remains constant. That is, energy cannot be destroyed or created. The conversion of energy principle also forms the backbone of human being diet industry. For example, a person who has a greater energy input than the energy output, so automatically the person will gain more weight energy in the form of fat. Next, law of thermodynamics and its limitations. The laws are zeroth law of thermodynamics and the first law of thermodynamics and its limitations and second law of thermodynamics and its limitations. Let's begin with zeroth law of thermodynamics. If we consider three systems A, B, C, if the system A and B are thermal equilibrium with each other, means automatically the system C also equilibrium with B as well as A. I mean, when the two systems are in equilibrium with the third system separately, then they themselves are equilibrium with each other. This is zeroth law of thermodynamics. Now we are going to discuss about what is first law of thermodynamics. When a system undergoes a cyclic process, the total amount of heat transfer is equal to total amount of work transfer. I mean, the heat and work are mutually convertible. In first law of thermodynamics, there are two limitations are available. First one is it doesn't specify the direction of flow of heat and work. I mean, heat flow from hot body to cold body or cold body to hot body. And second one is the work can be converted fully into heat energy, but the heat cannot be converted into fully mechanical work. And the second law of thermodynamics is, one is Kelvin-Bloch statement, another one is Clausius statement. We can say the heat energy given to the engine cannot be converted into useful work, and some amount of heat energy will be rejected to the sink. See, for example, you take heat engine. The heat engine receives heat from the high temperature reservoir and utilize the heat, produce some amount of work, and finally the some portion of energy, I mean the heat energy, is rejected to the low temperature reservoir. So the some portion of energy is lost here. So it is impossible to construct a heat engine working on a cyclic process which converts all the heat energy supplied into equal amount of work energy. And Clausius statement. The Clausius statement is heat cannot flow from cold reservoir to hot reservoir without any external aid, but it can flow from hot reservoir to cold reservoir without any external aid. Next, types of thermodynamic systems. That is open system, closed system and isolated system. What is open system? Open system means both mass transfer as well as energy transfer will takes place. Example is air compressor. If you take air compressor, the mass transfer will take place as well as the heat energy will takes place. And what is closed system? For example, you take the piston cylinder arrangement, there is no any mass transfer is occur, only the heat energy, energy transfer will occur. And the isolated system, a system is not affected by the surrounding. The best example is entire universe. Next, the thermodynamic properties. See, there are two properties are available. One is intensive property or intrinsic property. Second one is extensive or extrinsic property. What is intensive property? Intensity properties are independent on mass of the system. If we consider a part of the system, these properties remain same. Example, pressure, temperature, specific volume, density. And when we come to extrinsic property, for example, mass, volume, total energy, weight, these properties are dependent upon the mass of the system. If we consider a part of the system, these properties have lesser value. Next, what is state, what is equilibrium, what is thermodynamic process? Now we start with state. It is a condition of the system at any particular moment. The state is identified by the properties of system such as pressure, volume and temperature. So this is called state. And what is thermodynamic equilibrium? I mean, equilibrium means there is no any change with respect to time. I mean, steady state conditions. So the system is thermodynamic equilibrium means there is no thermal equilibrium, mechanical equilibrium as well as chemical equilibrium. Next, the thermodynamic process. Now we are going to discuss about few process. I mean, reversible process, irreversible process, flow and non-flow process and quasi-static process. What is reversible process? Consider a system. A system passes through an infinite number of continuous equilibrium states and it traces the same path when the process is reversed is called reversible process. So the best example is constant volume process, constant pressure process, isothermal process, adiabatic process. If you go for irreversible process, it doesn't specify the same path when the process is reversed. Example is free expansion process, throttling process, steady flow process. Next, what is flow and non-flow process? If you take boiler or turbine or compressor, after the process, the working fluid leaves to the atmosphere once the operation is over. So this is called flow process. When you go for non-flow process, the same working fluid is recirculated again and again. It doesn't leave the system after doing work. The example is refrigerator, air conditioning. These are the example for non-flow process. What is quasi-static process? A system passes through an infinite number of continuous equilibrium states and attains the original state when the process is reversed. This process is called as quasi-static process. Next, work transfer. Now, what is work? Work is an energy interaction between system and surrounding. Usually, energy can cross the boundary of any system in the form of either heat or work. But the energy crossed through the boundary in a closed system is definitely the form of work. So work is equal to force into distance. I mean, how many distance the object is moved. W is equal to F into X Newton meter. Types of work. Usually the work is classified into two types. One is a positive work and negative work. What is positive work? What is negative work? See, if you take heat engine or turbine, the work output from the system is taken as positive work, and if you take a compressor, heat pump, fan, work supplied to the system is taken as negative work. Now, what is modes of work transfer? The first one is mechanical work and non-mechanical work. What is mechanical work? For example, moving boundary work, gravitational work, acceleration work, spring work. These are the works under comes mechanical work. If you go for non-mechanical work, electrical work, magnetic work, electrical polarization work, these are the work under comes non-mechanical work. Next, concepts of temperature and heat. What is temperature? There is no exact definition for temperature. Based on physiological sensation only, the level of temperature is expressed qualitatively in words like freezing cold, warm, cold, hot and red hot. The mercury thermometer is used to find the temperature. And what is heat? The heat is defined as the energy crossing the boundary of a system due to the temperature difference between the system and surrounding. We can denote it by Q is equal to mc delta T. I mean T2 minus T1. Here mass and specific capacity, Q means heat, and temperature difference, final temperature T2, initial temperature T1. Now what is point function? When a gas undergoes a change from initial value to final value, the thermodynamic properties will change. What are the properties? Pressure, volume, temperature not depend upon the path followed by the system. It's purely independent of the path followed by a process. These properties called as point function or state function. Now what is cycle? Cycle is a series of state changes such that final state is identical with initial state is known as cycle. Usually there are two types of thermodynamic cycle. One is closed cycle, another one is open cycle. Here what is open cycle? Working substance is exhausted to the atmosphere after the completing the process. Both mass and energy transfer takes place. If we go for closed cycle, working substance is recirculated again and again within the system or without taking any mass transfer. Now what is ideal gas and real gas? Now an ideal gas is an imaginary substance that obeys the relation, that is pressure volume is equal to RT, PV is equal to RT relation. So the state equation is also known as ideal gas equation. At low pressure and high temperature, the density of gas decreases. At the time the gas behave as ideal gas. At the same time, at high pressure the gases start to deviate from the ideal gas behavior. That time the gas is called as real gas. Next, a thermodynamic process. I mean, a gas may be heated or cooled or expanded or compressed by different methods. According to the above, there are different process or given below. I mean, first one is adiabatic process, next one is isochoric process, and next one is isobaric process, and next one is isothermal process. What is adiabatic process? A process that has no heat transfer into or out of the system. It can be considered fully perfectly insulated. The other name of adiabatic process is called isoentropic process. Iso means constant, entropy is S. So entropy is constant. The notation of entropy is S. Next one is isochoric process. Isochoric means the volume is constant. I mean, here volume V is equal to constant. So entire the process there is no any volume changes will occur. And when come to isobaric process, iso means constant, baric means pressure. Here the pressure is constant. So at initial stage to final stage, the entire process there is no any pressure change. The pressure is constant throughout the process. And third one is isothermal process. I know we know already. Iso means constant, thermal means heat. I mean, temperature is constant entire the process. If you take any process, the initial temperature is, for example, 30 degrees Celsius, means finally the temperature will be 30. So this is called isothermal process. Thank you for watching this video. Thank you once again.